This video gives you some examples on proving trig identities, section 8.3.2 in the pre-calc text. So the whole idea with proving trig identities is you start with an equation like this one in example 1, and we're trying to show algebraically that the left side and the right side are equal to each other. So usually we have to use some other identities to prove new identities. And so some of the identities that are useful typically when you're trying to prove new identities, we definitely need to know our Pythagorean identities. So you have cosine squared x plus sine squared x equals 1. So that's probably the most important identity that you would need to know. And then if you take that, we get our other two Pythagorean identities. If you divide everything by cosine squared, you would get cosine squared x over cosine squared x plus sine squared x over sine squared x equals 1 over, we're dividing everything by cosine squared. And if we simplify, we get 1 plus tangent squared x equals secant squared x. So that's another Pythagorean identity. So we have this one. That's the primary Pythagorean identity. And then we have this one. And then if we take this one and we, instead of dividing everything by cosine squared, what if we divide everything by sine squared? We would have cosine squared x over sine squared x plus sine squared x over sine squared x equals 1 over sine squared x. And then this becomes cotangent squared x plus 1 equals cosecant squared x. So that's our third Pythagorean identity. So those three identities will sometimes be useful when we're trying to prove no identities. And then, of course, knowing the reciprocal trig functions. So in other words, whenever you see secant x, know that that is also the same as 1 over cosine. And when you see cotangent x, that's also cosine x over sine x. Even tangent, writing it as a fraction is sometimes helpful. So knowing that tangent is equal to sine x over cosine x, and cosecant x is 1 over sine x. Knowing those definitions is also going to be useful in proving a lot of identities. So let's take a look at example 1. What we want to do is show that one side is equal to the other side. So I'm going to start off by expanding this. So if we multiply cosine x minus sine x times cosine x minus sine x, we get cosine squared x minus sine, cosine sine, and then minus another cosine sine, so that's minus 2 cosine x sine x, and then negative sine times negative sine is positive sine squared x. And then if we move these next to each other, we'd have cosine squared x plus sine squared x minus 2 sine x cosine x. And there's our Pythagorean identity. Cosine squared plus sine squared is equal to 1. So we have 1 minus 2 sine x cosine x. And that now matches the right side, proving that the left side is equal to the right side. Okay, so let's take a look at another one. So in this one, we do have some functions that can be written as fractions. So for example, on the left side, tangent can be written as sine x over cosine x, and secant can be written as 1 over cosine x. And by writing them that way, we see now that we have a common denominator, and we can write that as sine x plus 1 over cosine x. And I don't see immediately how this left side can match this right side. So now I'm going to do some work on the right side. What I notice here is that we have a difference in the bottom, 1 minus sine x. And so what I'm going to do is I'm going to try multiplying by the conjugate, 1 plus sine x, on the top and the bottom. The reason why I'm doing that is because when you multiply two conjugates, you always end up with a difference of squares. And so here up on top, we would have cosine x times 1 plus sine x. And then in the bottom, we would have 1 minus sine squared x. And that comes from our Pythagorean identity. We know that cosine squared x plus sine squared x is equal to 1. So that means cosine squared x is equal to 1 minus sine squared x. So since I have 1 minus sine squared, I can write that as cosine squared and now this cosine cancels with one of those, so we're just left with 1 plus sine x over cosine x is equal to sine x plus 1 over cosine x, showing that they are the same. Okay, here's a third example. Go ahead and pause your video, try this one out on your own, and then press play if you aren't able to get it and you want to see the solution that I came up with. Okay, so first I see that there's a cotangent function. By the way, there are always different ways to go about solving these. So just because maybe you solved it a different way than I did, that doesn't mean yours is wrong. There are typically lots of different paths you can take to prove that one side is equal to the other. So what I'm going to do is I'm going to write cotangent as cosine squared over sine squared. And in order to add these, I need a common denominator. So I'm going to put sine squared in the bottom and in the top to get a common denominator. Now that I have the same denominator, I have cosine squared x minus cosine squared x sine squared x all over sine squared x. And then if I factor out a cosine squared from the top, I have cosine squared times 1 minus sine squared over sine squared. And cosine squared over sine squared is cotangent squared. Actually, let me write it like this. I'm just going to write cosine squared x. This, by the Pythagorean identity, is also cosine squared x. And so then this is cotangent squared x. And then we just have cosine squared x times cotangent squared x. And that matches the right side, cosine squared x, cotangent squared x. And so I was able to show that the left side was equal to the right side just by manipulating the left side. So now that we've done these three examples, I want to point out that in none of these examples did we ever add or subtract something to move it from one side of the equation to the other. So when you're proving identities, you have to leave everything that's on the left, and everything that's on the right. So never will we add the same quantity to both sides of the equation. Never will we multiply or divide both sides of the equation by some quantity. We leave the left side where it is. We leave the right side where it is. You can change the left side. You can change the right side, but never move anything from one side to the other. That's it for today's lesson. Have a great day.